All right, so the answer to the evens, starting with number 20. Part A is 10,800 joules, or 1.08 times 10 to the 4 joules. Part B is 2.70 times 10 to the 3 joules. Part C is 43,200 joules, or 4.32 times 10 to the 4 joules. Number 22, Part A, 240 point joules. Part B, negative 176 joules. Part C is 64 joules. 23 is odd. 25 is odd. 26. The answer is 19.0 C. And 27 is odd as well. All right. Anything you folks want to go over? Ruben?
For 26, if I wrote 19C, would
I no. I don't think so. Anything you want to go over? Maybe you weren't sure if you did the correct work, showed the right work. You can't just put answers down. You have to understand that. You just put an answer down. I'm not even talking homework, on a test. A lot of you got correct final answers on the tests, but you're not showing me how to get it, which means you get no credit. And that's why you lost credit on stuff on the test. Matt? Why is 22B negative? Okay, so let's look at what the question states. I got to review what it states again. So this is chapter 6. 22 states that a 6 kilogram box is being raised through a distance of 3 meters. Okay, the box is going up 3 meters. And in part B, I want to know the work done by gravity. Which way does gravity act? Down. They're anti-parallel. The angle between the displacement and the force is 180 degrees. Remember, when you do this, it's W is FD cosine theta. Cosine of 180 degrees is -1, and that's why you get negative work done in part B. Okay, but FG is negative. You have to include direction here. Now that equation, as W is FD cosine theta, which is essentially the same thing, those only work. Listen up. That equation only works if the force is constant. So as soon as you have a variable force, that equation has to get thrown out the window. Now you have to use calculus. The work is the integral of the force with respect to displacement. You'll need to know what the equation of the force is, which is what you had to do in which question? Number 26. You had to do an integral there for that. Same thing in 27. You did not have a constant force. The force value is changing over the displacement. So now you got to use calculus. Ruben? 27. Okay. So 27 states that we have this force, f of x, which is negative kx minus ax squared, where x is a distance of stretch, x and a are constants. And they want you to find the amount of work done as that leash stretches from x equals 0 to x equals 1. All right, so let's go over what you're going to do. This is a calculus problem because the force is not a constant value. You're not going to take that force and multiply it by x1. That would be incorrect. So what we have to do, since the force value is a function of displacement, we want to remember how we would get the work. The work would be the integral of the force with respect to the position, and we're going to evaluate that from an initial position to a final position. Okay? You're going to have limits or bounds on your integral that you're going to evaluate between. So let's go ahead and make a substitution here. I know that the force function in 27 is negative kx minus ax squared. And we're going to evaluate that between an initial position of 0 and a final position of x1. Okay, so let's evaluate the integral first. You know how to do the integral on this? This is x to the first power. So this would be negative k x squared over 2 minus ax cubed over 3. And now we're going to evaluate that between an initial x value of 0 and a final x value of x1. So let's go ahead and plug in. So that's negative k. The final values are always known first. X1 squared over 2 minus ax1 cubed over 3. And then we're going to subtract. It's always final minus initial. So negative k times 0 squared over 2 minus a times 0 cubed over 3. Of course, all of that is 0. It's going to drop out. So what is my final answer? Negative k x1 squared over 2 minus a x1 cubed over 3. And that is the amount of work that's done. Okay? Anything else? Sure. 26 is the same idea, where in number 26 it says that we have a force that is cx cubed. C is a constant. And I want to know how much work is done as I move from an initial position of 1.5 meters to 3 meters. So work is the integral of the force with respect to position, and we're going to evaluate that between an initial and a final position. So my force function in 26 is cx cubed. This tells me what the variable is. If I had put dc, then c would have been my variable, and x would have been my constant. My initial position, we are told in 26, is 1.5 meters. My final position is 3 meters. All right, so let's evaluate the integral first. The integral of cx cubed would be cx to the 4th power over 4. You add 1 to the power, divide by the new power. I'm now going to evaluate that between my initial position of 1.5 meters and my final position of 3 meters. This is how the notation you use to show how you're doing it. This tells me what you're evaluating between. Now we're going to work that out. So that would be c times 3 meters to the 4th power over 4 minus c times 1.5 meters to the 4th power over 4. Bless you. So I'm just going to factor out the c over 4. So that's 3 to the 4th power minus 1.5 to the 4th power. And then multiply that by c over 4. So let's evaluate that. 3 to the 4th power minus 1.5 to the 4th power. Divide that by 4. And that gives me 18.98. So that just gets multiplied by c. So that would be 19.0 c with the 3 sig figs that the textbook would like you to use. Okay. Anything else? No? Okay. So for tomorrow, you have assignment 30 to complete. Chapter 6, problems 30, 31, 35 to 40. So there are 8 questions for tomorrow to complete. Okay, that's question 30, 31, and 35 to 40. I'll give you the time to work then, okay?